Okay, let's talk about magnetic materials. Lodestone was an early example of a magnetic material. And when you rubbed it against something made of nickel, cobalt, or iron, you could also get them to become magnetic. Only these metals are called ferromagnetic because they can be magnetized. Aluminum, no. Uh, any other metal you think of, no. Nickel, cobalt, and iron are special. Only they can be turned into magnets. So, why is a magnet a magnet? Um, inside all materials, we have atoms. Yes, atoms have electrons that are orbiting around them. Electrons spin. It's a property of them. They all have a spin value. There's two ways to spin. Usually it's up and down are the two terms that are used, but there's two different values of spin. And when an electron spins, anytime you get electricity moving, we're going to talk more about that, anytime charge moves, we get a magnet or a magnetic field. Okay? So that's why. And so if you think about it, inside a hunk of say nickel, there are moles and moles worth of atoms, and each one has the possibility to be a tiny magnet because each electron has its own spin value. Now, if I have a random piece of nickel, all those tiny what they call dipoles. Dipole is something that has two opposite ends to it, be it a north and a south, or in terms of, let's say, a molecule in chemistry, you can have a positive end and a negative end. Those are both examples of dipoles, and here we have all sorts of little dipoles in this piece of nickel, but notice they are random. And so when I look at the overall direction that they're all pointing, there is no overall direction because I'm getting cancellation, yes? One points in one direction, one points in the other, some point down, some point up, yes? Some point left, some point right. All these little tiny magnets are canceling each other out. However, if I could by chance get them to all point in the same direction, or a big majority of them to point in the same direction, then all these tiny little dipoles would all start to work together, and this thing would become a magnet. That's how I make a magnet. I get them all to align. Okay? If I bring a ferromagnetic object is brought into a magnetic field, the atoms can be realigned by the field. And in the lab I have a machine that that I plug in, and I take a magnet that's not working so hot anymore, yes, and I stick it in here, and when I plug it in, it creates a magnetic field in this area, and because I've got ferromagnetic metal here, it will start to turn these atoms and get them to all point in the same direction. It's a remagnetizer. An object can be demagnetized by getting its atoms to realign in a random way. So magnets lose magnetism if you heat them up. Another thing that you can do is drop them or hit them. Yes, if I take a magnet and I hit it with a hammer, that force would start to get these tiny little dipoles. It would start randomizing their direction, and it would demagnetize them. If I break a magnet, both of them, looking this piece, would still have a north, and this would immediately become a south, and a north and a south, because of the idea of these tiny little dipoles. And the strength of a magnet depends, oh, I already said it, depends on the number of aligned dipoles. Yes. So there's a silly little meme troll talking about it, and luckily we have this guy from The Office who says false. When a magnet is broken, the other side becomes the positive negatives, and due to the fact that all magnets must have a north and south pole, he learned it in grade 5, and maybe you did, but if you didn't learn it in grade 5, that when you break every magnet needs a north and a south, and if you break one, you get two norths and two souths. You know it now.